Hello and welcome to today's webcast, NetBackup Troubleshooting Refresher Introduction, brought to you by DataLink, a division of Insight. I'm Amanda Sharp, Marketing Admin at DataLink, and will be your moderator today. Before we begin, I wanted to cover a few housekeeping items. This webcast is designed to be interactive between you and the presenter. The webcast console you are looking at can be customized. You can resize or move any of the windows that you have open. If you have any questions during the webcast, you can click on the Q&A widget at the bottom and submit your question. All questions from this webcast will be captured. If you're experiencing any technical difficulties, please visit the webcast help guide by clicking on the question mark below the presentation window. The help guide covers common technical issues. I would now like to turn this presentation over to our presenter, Chette Boardman. Chette, the floor is yours.
Thank you, Amanda, and welcome everyone to this afternoon's Tech Tuesday. We really hope you get a lot out of this one. Today we're going to take a little bit of a different path in our NetBackup. We're going to dive into NetBackup and really get an understanding of troubleshooting it, how it functions, and some of the internal processes that engineers use to troubleshoot this. So let's go ahead and get started with NetBackup under the covers. We'll start off with an overview of the NetBackup processes, and we'll move from there into the monitoring and logging, and then understanding those logs, and finish up with some of the tools that support uses to troubleshoot your issues. How many times have you called in for support and an engineer is going to ask you for various logs and support outputs and things? And you often wonder, what are they doing with it? Well, today we're going to find out. We're going to find out why it takes so long to go through these. We're going to give you a view into those. And we're just going to pull the covers back on NetBackup in general and see what happens under the covers there. Some of this may be familiar and some of it will be new, but either way, you're going to get a good foundation for troubleshooting NetBackup. So we'll start off with going through the NetBackup processes here. So we'll start off with that. So back when I started troubleshooting NetBackup, I went through a 4-week course, which ended up at the end of the course being given a set of logs for a job and being told to rebuild the policy based on those logs. And I thought to myself, well, this is going to be a challenge. And it turned out to be quite an interesting learning experience for NetBackup. And so today I'm going to try to share some of that with you and really dig into this. So to do that, we'll start at the higher level of this with the processes. NetBackup's not really a program, but more of a collection of processes that work together. The biggest concept in understanding NetBackup is that it's a collection of individual executables that all work together. Some of these are used to change settings from the command line, such as bp get config. Some are used to pull out information for review, such as NBSTL util report. And yet others are just services. They don't have any interaction. You don't execute them from a command line. They're just run, or they run with the NetBackup startup. The last group, the services, such as BPTM, BPCD, BPVRM, NBEMM, and quite a few others that we're not mentioning, fall into this category. It's kind of important to understand the process types, and so for the first level of that, we're going to dig into the naming convention a little bit. There are two different naming conventions at work here. Some of the processes will start off with BP, and those processes come from the legacy version of NetBackup. When it was first developed, it was known as Backup Plus, and then it was renamed to NetBackup. But a lot of those BP processes for Backup Plus are still around. They still do their job, and they do it well. There are other processes that start off with, they make their debut in NetBackup 6.0 basically, and they are designed for adding additional features into NetBackup. The NB processes to this point in NetBackup are additional features. The BP processes, some of them have retired, but the majority of them are still there. So anything that starts with NB is going to be the newer stuff, added for features or for expansion of the product, either at the master server level or others. Some examples of those will be NBRB, the resource broker, which allocates and tracks resources used for backups. Another one is NB Proxy. This is the piece that communicates between the newer processes and the older processes. So that's the background on your naming convention, BP or NB, and they still follow the same rule where just the first two characters designate the program. So let's dive into a little bit of what these processes do here. So as I mentioned, some run as a service, and these are started when NetBackup starts, and they stay running throughout the time that backup is running, not just running jobs, but from the time you start the services. Some of those will stay running. BPRD, BPCD, BPDBM, NBPEM, NBRB, and NBEMM are examples of these. They all have various responsibilities that they take part in. The nice part about this process strategy is that each process is responsible for a small portion of NetBackup as a whole. And we'll dive into that a lot deeper. The second group of processes we have are per job processes. BPVCAR, the backup, archive, and restore, sort of a misnomer there. It doesn't actually do restores, but this is an example of a per job process. This process will only launch when a job is running for a backup, and it ends when the job ends. There's one notable exception to this naming convention, that is the TAR process. And the TAR process is used for restore. It's a legacy process in the sense that it's been around since the beginning of NetBackup, but it still does its job very well. And again, these are called per job. So as a job starts up, these processes are spawned and they perform their specific task, and then they exit. So now that we have a high-level view of the processes, let's see how they work together. These processes are designed to work together to accomplish an entire backup, but no single process is going to handle that backup. It's done between multiple processes. And there are three ways those processes communicate. The first and most dominant is through the network. These processes talk to each other through the network, and this can even happen on a local host. It might happen on a media server where one process will talk to another through the network. And the majority of that traffic is going to be passing job parameters, spawning a process, or passing metadata back and forth. The data doesn't actually move locally through a network interface. That's one exception to that. Several processes are going to manage the communication: BPCD, VNetD, NB Proxy, and PBX. And diving into those a little bit, BPCD has a legacy process that handles the communication, and this will run on a master, a media, and a client, as well as VNetD. NB Proxy is what's used to communicate between legacy processes and the newer NB processes, so it's the translator between the two. And PBX is the port consolidation. This is private branch exchange that was developed to help control the number of ports that NetBackup uses. The final method is the use of event files. These are files that one process will create and leave in a specific location, and another process will pick up that file based on a timer or some other form of a trigger. It'll pick up that file and process that file, and based on that, will perform the work that needs to be done. So the command line parameters, which I jumped past here, I want to dive into this one a little bit more because this is one of the key aspects to understanding the logging, which we'll get into later. But I want to point out the example here of a process called, and then we have -R, and several other switches. And these are setting up the job parameters. So this is launching the BPV-CAR-V process with these switches. Another example here you can see, and this is a little bit different, is that BPBRM spawn child. So this is a process being called by, it's calling itself, but as a child. And so that'll typically happen when a process needs to perform a subset of its responsibilities. It'll spawn a child job and say, hey, go do this, and then report back to me when you're done. And then the child process reports back to the parent process, and then it will exit. So now that we have a little bit of understanding of the processes at a high level and the communication, let's kind of put this together and get a look at what's really going on. So on the right, you can see the different components of NetBackup. The blue divider lines are drawn to help show the different parts of NetBackup and help kind of separate it out. The master server is designated with the blue fill and the darker green components. And you'll see this line here kind of divides the processes. So these processes run on the master server. Below that blue line, the yellow processes are typically your media server processes. And then to the right of the blue line will be the client side. These may all be the same host, but these are the different components of NetBackup. You may have the master and media as one host and a client as a second host. You may have them all be on one host. If it's a catalog backup, the master server is also the media server, is also the client in some instances. You will notice that some of the processes are shared and show up in multiple locations on this chart. And that's a good example of this is BPCD. This is a communications daemon, and this is going to be on all the nodes so that they can talk to each other. One of the key takeaway points to this slide is to see the different parts of NetBackup that work together. So you can see the master server, media server. Another one that we haven't touched on yet is the storage server. We're going to get into that a little bit, and then client. And you also see that we're talking about API here, and this is another one I want to point out, and we'll discuss that. So storage server is a good example of this is data domain or a DXI that you use the OST plugin for either one of those. Those are third-party storage devices. They do back-end deduplication. This is the server that's going to ingest data. These typically accept connections through the network. So the data is sent to them, and then they deduplicate it on the back end. MSDP is another one. This is built into NetBackup. Even though it ships as part of NetBackup, it's still a separate component. MSDP is talked to through the network interface where the metadata is passed, and then data is sent to that MSDP engine, which writes it out to disk. The second one that I want to talk about is API, and these are NDMP filers, VMware, and Hyper-V are other good examples of this. In the case of an NDMP filer, you don't install a NetBackup client on this. It has a industry standard protocol, NDMP, that is an API. NetBackup talks to it through an API, which is just a translator. So NetBackup will say to the filer, back yourself up, and you have a tape drive attached to this port, send the data there and tell me about it when you're done, and then NetBackup will take that data and put it into the catalog. So it's kind of a traffic cop in that sense. With VMware and Hyper-V, we're just going to leverage the API to handle the workload. Instead of NetBackup having to have specific processes to perform actions in VMware, why not just leverage the built-in API and say to VMware, take a snapshot of this virtual machine and send me the details. Or in the case of a restore, we'll say to VMware, I need to create a virtual machine, and we'll pass the parameters. The name should be this. It should have one processor. It should have this much RAM. It should have a virtual disk. So it's very much like going into vCenter and creating the virtual machine yourself. We're just passing those parameters through an API, and it's much the same. One further note I want to add in here is the upgrading process. Since NetBackup contains multiple components, there is an order that these do need to be upgraded. it should always be updated from the top down. And the top of that tree is going to be Op Center. So you want to update Op Center first. That's where it's going to collect all the data about reports for you. So that should be updated first, and it should be at the highest version. Followed by your master server. Since this is the guy that's handling all the job data, the job initiation, that one should be updated after Op Center. Followed by the media servers, and then the clients. The nice thing about NetBackup is you don't need to update them all at once. You don't have to take NetBackup down and Op Center down and then upgrade them all and then bring them all back up. You can do this over time. And there's backward compatibility built in with limitations, of course. You wouldn't run 5 versions older of a client or media server without some issues. So it is backward compatible. An Op Center, as I mentioned, must always be at the highest level. So you don't have to have your master server at the same version as Op Center. It can be a version lower. It shouldn't be a version higher, though. That can lead to some issues with reporting and things like that. So now that we have a view of all this, let's move into how does this work together. So in the upcoming slides here, we're going to go through a sample of a very basic backup job, and we're going to see how these processes work together to perform a backup. So we'll start off with the NBPEM process. This is the Policy Execution Manager. So it's going to check for resources such as the max jobs per policy, which is set in the policy, or as well as other throttles that can be in place. For VMware, this is a little bit different. Hyper-V has some throttling, things like that. But this is where it's going to start. NBPEM is going to do that. And it's going to send a start request to NBJM, which is the job manager. NBJM is going to turn around and contact BP job D. So you'll notice we've gone from an NB process to a BP process. So we're going to leverage that NB proxy to handle that communication. So NBJM is going to reach out to BP job D, and it's going to add the job to the job database. The job will now show up in the activity monitor, and it'll show in a queued state. The next thing that will happen is NBJM, the job manager, is going to request the needed resources. So it's going to reach out to the NBRB process. This is the resource broker, and it's going to request the resources that it needs for the job. This could be a tape drive, a job ID. It will also request things like how many streams can we have from a particular client, and if we have enough streams, it'll request to get one of the streams. So if you have a maximum jobs per client set to 5, when this request happens, RB will say, well, I don't have any jobs going for that client, so I'm going to give you stream 1. So NBRB responds back. NBRB then reaches out to NBEMM. So this is the NetBackup EMM database to create the allocation and lock the resources. So NBRB is creating an entry in the database that says this job ID has 1 stream from this client. It's using this tape and this tape drive. So it creates that resource request and ties it to the job. NBRB then confirms that NBEMM has locked the resources, and once it gets that confirmation, it reaches back out to NBJM, the job manager, and passes that information along. NBJM will contact BP job D to confirm that it has the resources and tell it that the job can go active. So at this point, the job is going to go active. NBJM will contact BPDBM. This is the database manager using the NB proxy service to create the image DB record. So now we're creating the image database catalog entries, and we're opening that record and creating it. NBJM uses BP compat D. This is a compatibility daemon to pass arguments to the BP BRM process. This is BP Backup Plus, as we said, Backup Restore Manager. So this is the media server process that's going to be responsible for managing the backup or restore that's happening. And this, you'll notice, happens on the media server. BPBRM contacts BPB car on the client. So now we're moved over to the client. And so we have staged everything, and we're kind of working down through the processes. So BPB car is called on the client, and it sends the file list. So it tells BPB car, hey, I need you to start up, and here's your list of files. And then contacts BPTM. This is the tape manager, and it's a little bit of a misnomer. BPTM handles backup data to disk as well. And it passes along the allocation ID got earlier when it talked to NBEMM. BPTM will contact LTID, TLDCD, this is the tape library daemon, and AVRD to mount tapes. So this is if it's a tape-based job, these processes are added in. And this will all change as jobs are passed along with different parameters. A SQL job will look different than an Oracle job, will look much different than an Exchange job, but this is a basic backup job, and some of the processes are the same. What the processes do is the same. So we'll move on to the next part of this, and we'll continue the same backup job. BPB car now sends the data to BPTM. So we have all the media server components have been taken care of. We've allocated resources. We've allocated a tape, and we have it loaded in the drive if needed, and we're ready to go. So BPB car sends the data to BPTM child, which puts it into buffers. BPTM parent pulls the data from the buffers and puts it to storage. Once a fragment has been moved, BPTM is going to contact the BPBRM process to update the image database. It's important to note here that a fragment is not going to be the entire backup job. This is going to be whatever the fragment size is set to. Once that fragment has been completed, we're now going to update the catalog information. We're going to pass that information along. So we're partway through the job. A job may be 100 fragments. It may be 5 fragments. But each one will pass that information along, so we don't wait too long on that. Once all the data is backed up, now we're going to start to back out of the job. We're going into the job completion portion. So the first process, BPB car, will send the image summary to BPBRM. So what's happening here is the client side, BPB car, has passed all the data over, and it's all been written out to storage. So now it's going to say, hey, I've sent everything over. So now it tells BPBRM, the Backup Restore Manager, hey, here's the image information, here's what we've backed up. And then it's going to close the connection to BPBRM. So it's going to close that connection out, and the BPB car process will then exit. It will also close its connection before exiting to BPTM, where it's been sending that data, the child process. So at that point, BPB car and the client-side work is done. So now it's up to the media server. So you'll notice we're going backwards through. We started off, we went from master to media to client. Now we're backing out of that since we've completed the job. So BPBRM sends the image information to BPDBM, the database manager on the master, and notifies BPJobD that the data has been backed up. So now we're finishing up that part. BPBRM waits for BPTM to confirm exiting. So what's happening here is BPTM is writing out all of its data, the last bit that it was sent from the client, and confirming, hey, I wrote it out, I didn't run into any problems, and now I'm about to finish up what I'm doing. And then once it does, it'll tell BPBRM, yep, I'm all set, I'm exiting. BPBRM then ask BPDBM to validate that the image is complete. So BPDBM is going to verify that, yep, I have all the data, I've written all the catalog entries, and the image is valid and good. So from that, NBJM tells BPJobD to mark the job complete in Activity Monitor and deallocate all the resources by notifying the NBRB or resource broker. So now we're stepping back out of that part. BPBRM is exiting, and the master server processes are now backing out of the job. So all the allocations for the tape, the client stream, and all of that are being deallocated and released back. And then NBJM, the job manager, notifies NBPEM, the Policy Execution Manager, that the job is complete, and then update the next due time for the policy. So what's happening here is that NBPEM is saying the job is complete, and then what it does is it calculates based on the job schedule when is the next time this job should run, and it puts that into the database. And at that point, the processes are now going to exit that should exit. So that's a lot going on there between master media and client, and depending upon if they're three separate physical server or three separate servers, I shouldn't say physical, if they're three separate servers or if they're all on one, these processes can take a little more time, and there is going to be, in the sense from the client to the media server, if they're two separate servers, that data is going across the network. So that's going to slow things down based on various things, network traffic. It may be extremely fast if it's a 10 gig connection. An older client with older hardware may be a bit slower, but the process is the same whether it's local or remote, just the speed changes. So now that we've run through that, let's look into what happens when it goes wrong. Where do we start troubleshooting that? So starting off with logging types, this is where we get into the actual troubleshooting of things going wrong. Very much like the process names, the logging types are different based on the processes. BP processes use legacy logging. These are the single-threaded processes, the legacy processes, which means that each time it launches, it gets a new PID, process identifier, and we'll get into that in a little bit when we dig into the logging. An enhancement to the legacy logging is robust logging. With the legacy logging, the way NetBackup handles that is when the process starts up, for example, BPV-CAR, when it starts up, the very first thing it does is look for its log folder in its designated location. On a non-Windows client, that will be user openv NetBackup logs, BPV-CAR. So the logging folder is the same name as the process. So the process starts up and it looks for its logging folder. If it exists, it will then open the most recent log for the current date and start logging what it's doing. And the first thing it's going to do is note its verbosity level and where its logging is set. The robust logging is an enhancement to this because it allows you to control the log size. With legacy logs, you can control the verbosity of those logs, and it varies based on which component you're logging, whether you're logging network traffic or the process itself or all of it. These logs can get very large, and there's no mechanism to prune those logs. Robust logging was an enhancement put into place to help prune those logs, and you can set up various parameters such as how much of the log to keep, how big should each log get before it generates a new one. There's a lot of configuration in how you can control log sizes, even how long to keep logs for. So that was a real big enhancement to the legacy process, which was limited in controlling log growth. The third type is VX logging, and this was implemented with release of NetBackup 6.0 and has continued to evolve. These are the newer processes, the NB processes. And this is more of a database type logging. We're going to log into a database. We're going to store the record for each log entry in these databases, and we're going to use a tool to pull it out. They're still stored in the same location based on the process name. It's just that the structure of the log changes, and we'll see some examples of that as we get into this. To retrieve those logs, to translate those logs, we use the VX log view to quote-unquote query the logs and extract the details. And this gives us a lot of flexibility in how we can pull that log out. With the legacy logs, you're looking at a full log and you have to sort through it to find what you need. The VX log view changes that and gives you the ability to focus in and grab just what you're looking for out of there without having to have the full log, and we'll get into that. The key benefit is that it's far more manageable. When you enable logging, you set parameters as to the verbosity and you can control how long they're kept, how big they can get, and you can even do this per process and per function of the process. And as I mentioned before, it allows for gathering of the specific details that previously would require you to gather the whole log and then scan through the log to find what you're looking for. Some of the key features you can query by are PID. You can query by timestamp to get a certain timestamp out of those VX logs, as opposed to the legacy logs where you would have to pull the whole thing and parse out the PID. And we'll get into that in a little bit here. So that's a high-level view of our logging types. So let's dig into a little bit of the logging levels, and these determine what level of logging we're going to use for the process. Are we just going to capture that high-level information, capture all the errors, but we might not capture all of what it's doing? Or for more complex issues, you may want to increase that verbosity to get more details, to see all the informational and what exactly is it doing. So we can increase the log levels from 3 locations for the legacy processes. We can do this from the master server. This is done by expanding host properties and selecting the host type and then the host. So if we're logging legacy processes on the master, we're going to choose master server under the host properties, and then we'll pull up the properties for the master server and increase our verbosity there. For clients, we'll go host properties, expand out clients, locate our client, pull up its properties, and adjust the logging from that level. The second method to do this is we can do this from the client. For a Windows client, we're going to open the bar GUI, run it as administrator. We'll go to File, NetBackup Client Properties, choose the Troubleshooting tab, and increase our verbosity there. One quick tip that helps a lot with this one, in the bar GUI, if your logging levels are set all at the minimum levels, to get to the maximum level, just simply click the down arrow. So if the logging level is set to 0, clicking the down will set it to its highest level, so you don't have to go and click it multiple times. That's just a quick tip to help with that. So for Linux clients, it's a little bit different, and that's done with this method here, and this is bp.conf. On non-Windows systems, you can change the level of logging by adding an entry to the bp.conf file. And so what you'll put in there is verbose, space, the equal sign, space, and then the level of logging that you want to use. The bp.conf file is located in user openv NetBackup. An example of that here, you'll see we've set verbose equals 5. So this is going to be verbose equals 5 will apply to all of the legacy processes, and all of them will be turned to their highest verbosity. There is also the ability to specify specific processes for logging level. And there's a large list of these available out on Google. If you search for them, you can find the articles that talk about the various processes. But the general rule of thumb is that you'll have the process name underscore verbose space equals space and then the level of verbosity that you want to use. It's important to note that these are case sensitive, so they have to be entered all in uppercase, and that space is important. To put these changes into effect for master server, you can use this command here under user openv netbackup bin, and the command is bp-rd req space dash reread config. This tells NetBackup to read that bp.conf file and put those changes into effect. This will only happen for per job processes. It will not apply to services that are already running. And the reason for this is, as I had mentioned earlier, that when the process starts up, the first thing it does is look for its logging folder. Once the process is started, once the process is running, it's not going to go back and look for that folder. It doesn't check periodically. So once it starts, it gets its configuration. What verbosity should I be at? Does my folder exist? Okay, I'm started. And that's it. So to put those changes into effect requires that you stop and restart the service for it to pick up its logging level. And this applies to legacy processes. For the media server, the processes that are running as services, it works the same way. If you increase the logging level, you have to stop and restart the services on the media server and the client for these legacy processes. However, for processes that are per job, such as BPB car, when the job kicks off, it'll launch BPB car, and BPB car will check what verbosity it should be logging at and if its log folder exists. If it finds that its log folder exists, it will then start logging at the verbosity that it found that it logged at. So let's move on now. For logging levels for our NB processes. So these will use the VX logging. The robust logging is an enhancement to the legacy logging. This should actually be on the previous slide and tied to the legacy logging, but you can configure these within the GUI on the master server as well as the client. You can also configure it from a GUI on a media server connected to the master, but these are configured to control how often to prune out old logs, how big should they get. It's a great way to control the space utilization. But for the newer processes, VX logging is what it uses. So these are configured through the command line or through the GUI in the same method as legacy in terms of where they are in the GUI. Some of these processes, such as NB EMM, NB proxy, and PBX, have to be configured to log through the command line. The command line uses VX log config or VX log CFG here, and this allows you to adjust the logging levels from the command line. These are dynamic, and it happens right away. As long as the folder exists, the process logging, when you change the verbosity, it happens right away because these are the newer processes and they're using a different logging method. And as I said, they take effect right away as long as the folder exists. You'll use VX log view to retrieve the logs out of here, and this is where that flexibility comes in. A good example of this here was we see a sample VX log view when we're pulling out some logs. So we're going to use VX log view -P for the program ID. In the newer versions, NetBackup is program ID 51216. This is an optional parameter. If you specify this, this limits the querying of logs to NetBackup only. If you're using other applications such as Storage Foundation, you may not want to include those logs. In that case, you'll limit it by the -P. -O is the origin ID, and in this case, this is in the form of a 3-digit number. So we're going to use an origin ID. This is a specific process we're going to query. We have the -T, which is time. And in this example here, we're saying -T, we're going to reference a time frame. So in this instance, when you run this command here with these parameters, we're going to say, give me all logs for the last 1 hour and 30 minutes. And this can be as little as a few seconds to a couple hours, and the log size, of course, will grow as that time frame is expanded, but it's done from the current time. So in this case, give me everything for the program ID 51216, which is NetBackup, for originator ID 117 for the last 1 hour, 30 minutes. And then we redirect that output to the NBJM text file. So -O117 is NBJM process. This article here will give you a current list of originator IDs hosted by Veritas. You can just simply go out to Google or any search engine and type in NetBackup OID list and click on the Veritas link, and you will get the list of originator IDs. That list does change as they add new processes. As old processes are taken out and replaced with newer processes, they have to expand that list. So it's always a good idea, if you're not sure, to pull up this originator ID list, go through that article, and locate the specific process you need. The nice part about using this VX log view, if you just simply want to see everything that's going on for every product, you can simply get rid of the -P and -O and say VX log view -T 01:30:00, and that's everything for the last 1 hour, 30 minutes, and dump it out to a text file. Of course, you can change this to whatever you want. So it gives a lot of flexibility for pulling out specific information. So now that we've seen some of the enabling of logs and a little bit on how to extract some of that information, let's get into it a little bit more with gathering up these logs. One of the best tools for this is the logging assistant. And as you can see in this screen clip here, in your NetBackup admin console at the bottom, the very bottom option along the left side is your logging assistant. And you can use that to actually gather all the logs from the master, media, and client. It will actually contact the client and extract the information for you. So let's just cover some of the methods to gather logs. You can do this one by one, and this is navigating to the folder where the process is logging. On Linux or non-Windows, that's going to be user openv NetBackup logs, and then whatever process you're looking to gather the logs from, change into that folder, and the logs will be there. And the file name convention will show the date of the log, so you can easily identify which log you want. We can use the VX log view command as we saw in the last slide, as well as here. This is another example where we're just going for the time frame, last 30 minutes. We have the logging assistant, which you will open the logging assistant. You'll create the record for what you want to log. So you'll need to do this before you actually have a failure to analyze. Before you recreate that failure, you want to go into logging assistant, create the record, and the wizard is very intuitive and will make suggestions for what processes to log, and it gives a very detailed explanation based on what you're doing. It gives you the option to analyze and make sure you get the logs you need. And then what you'll do is you'll enable that logging record, create the failure, and then use that same logging record to retrieve those logs for you. Another method through the command line, for those who love the command line, NBCP logs. And this is a command line tool to collect logs from other hosts. In Windows, it's in your installation folder, NetBackup bin support. For non-Windows, user openv NetBackup bin support. An example of the command you can see here, NBCP logs -s, and then you're going to give it the time frame, the start date, the end date, and a directory to dump to. It's going to ask you to confirm that there's enough space, and then it's going to go ahead and gather those logs. It can reach out to the client and grab the logs based on various switches that you can add to it. And as you see in the example below, you even have the ability to grab from MSDP or PureDisk, as well as some of the newer processes too. This works with the newer processes, the NB processes. So now that we've learned how to accumulate logs and let them build up, once you're done troubleshooting your issue, the next big thing to do is clean up those logs, turn your verbosity back down, and put the system back into a running state where it's just running and you're not necessarily troubleshooting an issue. You don't want those logs to build up and fill up your volume. This happens quite often. So this is one of those things that after you're done troubleshooting and you've gotten all the logs you need, it's a good idea to come in here and let's turn the logging back down. And so I've included the ways you'll do that. The first step is the cleaning up. And there's a real simple command for that. That's the VX log mgr-f, and that's a capital F. And what this does is tells NetBackup to purge all of the VX logs. Those are those new VX logs for the newer processes. What it's going to do is it's going to go out there and it's going to find any logs that are not actively being logged to. So these generate new logs periodically based on the parameters you set up. It's going to purge out all those old logs for you. It's going to get rid of them. For the legacy logs, you're going to go out there and you can do this in the GUI or the bp.conf to lower the logging level. In this screenshot, you can see based on the GUI, you can set the logging levels back down to their lowest levels. For some of the processes, BPBCAR, TAR, some of those processes, BPTM is another one. If it's not running, you can actually delete its folder. So if you have no jobs running, you can go out and delete that BPTM folder and all the logs it contains. The next job that kicks off that spawns a BPTM, it will see that the folder does not exist and it's not going to log. But it's always a good idea to turn these logging levels down as well. So let's move into reading these logs. We've gone and we've gathered them up. So let's dig into reading these logs and understanding them. So here's a sample job details, and this is just pulled from an activity monitor of a standard job. We've just run a backup here. We've got our backup ID. This is what you'll normally you luckily did with no issues. But we're going to take a look at this later. We're going to revisit this in an upcoming slide. So this is just a sample output. So it all starts off with, when you're troubleshooting, to understand where to look for things. So when you're tracking down an issue, it's important to understand where your processes are and where the process breaks down. A good example here, we'll just go over a basic one. A status 71 means that not all the files were backed up. So we passed the file list to the client didn't back up all the data. So we know we should probably focus on that client. And some of the job details are really going to help you with that. So from the job details, we'll just look real quick and see some of the information that's available to you. You have an end time. You have a job ID. You also have the error message and your time frame for when that's happened. So we have a job ID, and we can pull it out of the logs. A couple of quick tips in logs when you're troubleshooting. You can scroll through for a specific timestamp. Now these are the legacy logs. You can also look for process exit status, and you can just simply search for keywords exit status, and then you'll pull up a list of all the times the process exited, and you can find the PID that's identified for troubleshooting. Another way to look at these are line codes, and these are the severity of the line that's logged. 4, as you can see in this example, is just a report. It's an informational, it's logging what's going on. A 16 is a little more severe, and it tells you a little bit more about what happened, and here it's saying that media 1 is not a media server. So we'll dig into this a little bit more, but these are some of the quick tips. It all starts here with going into this job overview and getting the details on the job, and then from that knowing where to look. So let's dig into the log structure a little bit and understanding what you're going to see in these logs. The format is typically timestamp is your first column, process identifier is the second, severity the third, and then the message. So this is a standard format for the legacy logs. The timestamps are usually in a 24-hour format, so it's using military time. The process identifier is the unique value assigned to a process when it starts up. And there's a difference between Windows and Unix. For Windows, you'll see that it is one number dot another number. For non-Windows, it's just going to be one number, but they'll both be the same in their delineation here with the brackets, so you can know what you're looking at. And again, the severities, you'll see these are just some common. There are some others that you'll find as you're troubleshooting. And as you start to dig into these logs, they'll start to stand out even more to you. But as a general rule of thumb, 2 is an informational. 16 is something to note, but it may be an error. It may not be. If it's an error, it's usually a high level, like a final result code. 32 is typically a severe error, file system error, a process that crashed out, things like that. So some things to look for as you're digging through these logs. When a process starts up for the legacy processes, it typically will note what its verbosity is. So if you're not sure, did your logging level take effect? Right here when the process starts, initiating verbose equals 5. So you know that logging's turned up. That's a good thing to see there. For some of the other processes, for example, BPDBM, it looks a little bit different, but the general message is there for you to look at. Some of the things that we were talking about earlier in relationship to processes talking to each other, you can see a good example here where you can actually look at what's going on. This is a restore, and you can see some of the various parameters passed. The client is NBU master, the host name is NBU master. You can actually see what's going on here, even down to some of the logging, where it's logging what's going on. This is -L for logging, so it's logging to that location. And as you can see, it's passing the various parameters of the job in the switch format. Another thing you'll find in these logs is one process calling another process. In BPBRM spawn child, and it's spawning a child process for BPTM in this case. And it's passing along those parameters. An example of an error, we have our process identifier, we have our severity, and then we have the actual message. And you can see here, based on this port map, is trying to connect to an address. So this was an error message logged that something went wrong there, and that's a good place to start. You could either search for this 16 to kind of scan through the log at a high level, look through, oh, here's a 16, well, what was going on? Is this an error message? If it's a severe error, you might search for 32 to see if you can find it. These are good starting reference points to look through to see what's going on. One of the key points, if you are trying to find out what's happening with a process, you want to see what it's doing, a good place to start is to search for the entire PID. So in this case, you would search for the bracket 3749 and find all the lines with that and pull them out and put them into a separate log. And now you'll see a sequential steps of the process from beginning to what it's doing in order of what it's doing. So it's a great way to find out what's actually happening. So now let's go back to our sample job details here. And now let's start to pick out what's useful for us when we're just looking at a job details and we're trying to figure out where we're going to go to troubleshoot our issue. So you can see here, we're going to start a job, and you can see right away in the job details, there's our job ID. We know what we're looking for. So we can actually look at some of the command line stuff or some of the logging stuff, and you'll actually see -job ID is one of the parameters, and we'll see if we can see that here. As we're looking through on this previous slide, we should be able to see the -job ID. So it'll show up as a switch, and you can track a job and the process that way. So you might pull up a BPB car and look for the job ID, and now you have the PID. Pull out that PID and see what's going on. So that's just one useful detail. The other option, the other thing you can look for is the PID, and here you can see for MBJM, here's our PID, 5848. Another bit of useful information is the backup ID. So we can say, well, we know it's this client, and here's the image name. So now you can search through and find that. That is passed from process to process. We also have the policy name, the schedule, and in this case, the schedule is named incremental, and the storage unit it's going to, in this case, MSDP. Again, we see that PID. We also see the client name is listed, and we say, it states clearly client 1 is the client we're backing up from. We also see BPB car PID right here, 8616. So now if we were pulling out details for this being our failed job, we might just go to BPB car if it was a client-side failure and pull out 8616 PID, see what was going on at that time. We also have the BPTM PID. Some side notes, but something that is worth noting is we can also see our values for our buffers. We can see what size buffer we're using, the network buffer, and the number of buffers. It's a good thing to know. For performance tuning, there's a Tech Tuesday that was done on that, and this is referenced. So if you're looking for more information on that, our YouTube videos on our YouTube channel for DataLink will have that. You can also see our BPTM child process. So these are just from the job details, you can pull it out. You can see what pure disk storage server we're using. We can see the media server name, and we can see some of the deduplication information. Of course, we have our exit time here, but we also have our BPB card PID that actually exited, in this case, 8616, which you see up here, and it says it was done with status 0. In the case of a failed job, it's going to be a different status code. Status 0 means everything was done the way it should have been done. Status 1 says, I did most of what you told me, but not quite everything, so that's going to look a little different. You'll see status 1 there. So that's just from the job details. So let's look into some other tools real quickly that a lot of engineers will request this. There's a lot of good information. We're going to cover that here. So when we're troubleshooting an issue, a lot of times we're going to ask for an NBSU output. It sounds like a rather hammer approach, but it really contains a lot of information, and it's a great initial step to understand the environment we're working in. For appliances, we're going to ask for a DataCollect. That's going to give us some statistics about the appliance, what model it is, how much RAM, the processors, the size of the MSDP pool, and a lot of that information. So we really have a good understanding of what we're working with. We can really get a look at the environment without actually going into there because we don't have the ability to sit down and understand the full environment. The NBSU is going to gather a lot of information that really helps us. The next thing we're going to want to collect is application-specific logs, and these are typically internal to an application. A good example of this is SQL Enterprise Manager logs. So when you go into a SQL Enterprise Manager, you actually have those internal logs. Those will really help when troubleshooting a SQL issue. So we'll want to grab those. Exchange Server, SharePoint. For NDMP filers, the NDMPD process from the filer is a good one. The Oracle internal logging, Active Directory specific logging. There's a lot of good examples of logs to collect. So let's just talk about this NBSU real quick here. NBSU is the NetBackup Support Utility. It's going to gather a lot of the system configuration logs. It gets us the system and event viewer logs so we can actually look through there and look for process crashes, things like that. We get the network configuration and statistics. We get versions and file information, so we get a list of all the files that belong to NetBackup and their versions. It's only going to collect the NetBackup specific file information. We get hardware specifications for the system, how much RAM, how many processors, the hardware model, for example, a Dell PowerEdge R7 or Dell R710. We'll get network, it might be an Intel card, we'll find that information. And then we'll gather the NetBackup specific configuration. We're going to get a lot of the in-depth details. What does the bp.conf look like? What logging levels are turned on? What are the configuration? What does EMM have for a list of servers? All that. We also get the tuning and touch files used by NetBackup. So there's a lot of good stuff. How to run it? NetBackup support utility is located in the NetBackup bin support folder. Typically, you just run NBSU from a command prompt. For Windows, it needs to be an elevated command prompt. It's a non-intrusive test. It can take anywhere from 2 to 15 minutes to gather up all this information. It does not interfere with NetBackup. It can still run its jobs. It doesn't hinder the performance of it. It's a very lightweight utility. It is included with the NetBackup installation. When you install it, NBSU is there. So it's a very good tool for us to gather right up front. These are some of the log files it creates for us. These are the text files that it outputs once we extract it. So we can tell from this, based on the file name, you can see what group it belongs to, right? These are OS-specific logs here that start off with OS. We have net for the network statistics, and then NBU for all the NetBackup-specific stuff we collect. DataCollect, much like an NBSU, collects a lot of things. This is specific to an appliance. It's going to get the messages file, the system configuration and logs, the network statistics, NetBackup version, the hardware specs, the NetBackup version itself. We're going to get some of the tuning and touch files. We're also going to get the RAID card logs, hardware alarm logs, and the disk status, all the individual disks and how healthy they are. And it's going to perform a quick hardware test. All of this is non-intrusive as well. It will bundle that up into a nice little file, and we can collect that and open that up. It's all in text format, and understand the system we're working with. So with that, I've also included here a summary of the links that you've seen in this presentation, as well as some additional links that you'll find useful. So when you get a chance to go through this presentation, you can look at these links. We've included some examples of the MBCP logs, the OID list. We've got a NetBackup cheat sheet, which includes some of the common commands and an explanation of them. A big thing I'd like to point out here is the NetBackup late breaking news articles. There's 3 of them listed here, and they generate a new one for each new version of NetBackup. I would highly recommend going out and reviewing these articles and subscribing to the article. The nice thing about that is that if the article is updated with new information, you'll receive an email that the article was updated, and you are made aware of things proactively, what's coming up, what's changed. I've also included the links to the downloads for the NetBackup appliance manuals, and a master article for the late breaking news. It lists all of the late breaking news for all the different versions. I'd also like to include the link to the DataLink YouTube channel, which includes all of our Tech Tuesdays, as well as a large number of presentations and informational videos that will really help you get various products that we support. It also includes all the other Tech Tuesdays we've done on various products. And then finally, the NetBackup support site, the DataLink support site for our support services. I appreciate your time today. I hope that you found this very useful. I hope that this gets you peeking into your environment and seeing what's going on in there, understanding. And as always, contact support will help you out with any issues you run into and questions you may have. So with that, we're done with a status 0. The requested operation was successfully completed. Amanda, I'll turn it back over to you. Thank you for your time, everyone.
Thank you for attending today's webcast. An on-demand version of this webcast will be available within 2 to 3 days of the webcast. You will receive an email notification once the recording is available. Thank you again for participating in today's webcast.